This is Artems.ai. What matters in tech and beyond. The line between digital intelligence and physical action is blurring. We are moving from AI that simply predicts text to agents that can experiment, fail, and rewrite their own logic in the real world. Imagine a robot that doesn't just follow a script but actually experiments. NVIDIA has developed a software framework called ENPIRE that gives physical robots the same kind of autonomous loop that coding agents use. The system uses a set of modules to reset the environment, refine policies, and analyze logs to fix failure modes. It is essentially a harness for coding agents to manage real-world learning. In tests using NVIDIA RTX 5090 GPUs, these robots achieved a 99% success rate on complex tasks, like organizing pins or cutting zip ties. They are even practicing how to insert GPUs into motherboards. This transforms robotics from a manual programming task into a controllable optimization procedure. But as these agents gain more autonomy, they create a massive new attack surface. Researchers have identified a vulnerability called agentjacking. In control tests, a single fake error report sent through Sentry was enough to hijack Claude code. The agent executed the attacker's code with full developer privileges, and not a single security alert fired. This is what experts call the runtime yak. The security stack cannot distinguish between a developer running a command and an agent executing a malicious instruction. The scale of the problem is systemic. Only 14.4% of agents are deployed with full security approval. Most enterprises are now managing over 37 deployed agents, many of which are completely invisible. This vulnerability exists because most agents are still reactive. They respond to a prompt without a real internal map of the future. To solve this, new training paradigms like WMAMT are internalizing world models directly into the policy. Instead of just acting, the agent verbalizes a prospective state rollout and estimates a success probability. It is essentially a textual U-value that lets the agent prune bad paths before they happen. It reframes model construction as a foundry. Using sheaf theory and Toulmin arguments, it ensures that a claim is not just a token prediction, but a warranted upticket with a clear provenance. It turns the black box of AI into an inspectable architectural blueprint. While the technical architecture is becoming more structured, the regulatory environment is hitting a wall of friction. In Europe, the DMA is forcing Google to open up its search data and Android wake word access to competitors. Google warns that this is a privacy nightmare that could lead to mass re-identification of users. Meanwhile, the financial world is attempting to bring the same discipline to crypto. PNEA is expanding stablecoin services for USDC, and Ripple is proposing a lending protocol where the Blancac enforces the loan. We are seeing a clear rotation. The Wild West of crypto-native governance is being replaced by traditional banking safeguards and federal frameworks. Today's through line is the shift from reactive chaos to structured infrastructure, whether it is NVIDIA creating a closed loop for robot learning or BNY bringing institutional custody to stablecoins. We are now entering the era of the harness, where the value is not in the model itself, but in the framework that governs, secures, and verifies its actions. This was the Artems.ai. Agent tune in tomorrow.